Okay, guys, so we're going to work on this particular exercise. And what we're going to do is, obviously, suppose a carpenter makes 3 doors, small, medium, large. The profit he makes is 1,000, 1,300, and 1,500 respectively. The elaboration time is 5 hours for the small one, 7 for the medium, and 10 for the large one. The consumption to meter squared of wood is 2.4, 2.8, and 3.2 respectively. If you have 400 man hours and 300 square meters of wood per week, what would be your recommendation to the carpenter? Okay, if the demand studies estimate that at least 3 small doors, 5 medium, and 5 large will be sold, what are restrictions at? So let's do without that first one. And I have my variables right here. I'm going to just make this a little larger. This is small, medium, and large. This is what I want to know what's going to happen. My objective formula is going to be how much I can actually have a profit. So it's going to be 1,000 times the small one plus 1,300 times the medium, or however much solver is going to give me the medium, plus the large times 1,500. Okay, of the large. That's going to be my objective formula. And my restriction formula is going to be, the first one is man hours. And the second one is going to be square meters of wood. And the first one is going to be, and I'm not sure why I put it red. It's going to be the simple formula of 5 man hours for the small plus 7 man hours for the medium plus 10 man hours for the large. Okay, that should be less than or equal to 400. I don't have any more than the 400 hours. And the square meters is going to be basically the same amount. And if I want to be able to do that, I'm just going to put my formula down. That's why I'm able to do that. But it's going to be 2.4 meters for having small, 2.8 for the medium, and 3.2 for the. And that should also be less than or equal to 300. Okay, that one's very simple, very basic. We go to solver, and we're going to erase all our data right here just to make sure that we're understanding the problem correctly. And here it says, what is my objective? Well, this is my formula for objective. What am I trying to do? Maximize. Changing what? I want to see how many I have of the small, medium, and large. And my restrictions are this particular formula less than or equal to 400. And this one less than or equal to 300. Okay, make sure that it says no negativity. I cannot destroy doors, simplex, and I go ahead and do this, and it brought me to my other sheet. Okay, so now it says I need to make 80 small doors, no medium, no large. But let's look at the next part. It says if the demand studies that you at least need 3 small, 5 medium, 3 small, 5, 3. Can't actually read the first. 3, 5, 5. Okay, so I need to make sure that it says this, whatever this is, which is the small, should be at least greater than or equal to 5. No, to 3. And this number right here for the medium should be greater than. Why is it greater than? Because I can make more than the 5 doors. But I cannot make less because that's my demand is telling me. And that's going to be 5. So I'm going to go to my solver again. And I'm just going to add these restrictions. These 3 restrictions is going to be the same as these 3 restrictions. Okay. Again, simplex, I run it. And now I know that I'm just going to make the basics, what my demand is saying. 5 medium doors, 5 large, and that takes away a little bit from my small doors, 63. Okay. That's how you solve it. You're going to have in order to make your maximum profit, you're going to have 6 to 3 small doors, 5 medium, 5 large, and that's going to give you 77,000. Let's look at another one. Let me just close this one so that it doesn't keep opening. Okay, so here we are. Now we have, this is Portafern, is a company that manufactures calculators, radios, and tape recorders. The product here goes through 4 operations: cutting, molding, wired, and assembling. In each operation, 100 hours, you can use 100 hours. I mean, 100 hours for cutting, 100 hours for molding, 100 hours for assembling. And what we want to do is to make sure we have our maximum profit. Out of every calculator, we get $10. Out of every radio, we get 20. And out of every tape recorder, we get 30. So my variables, to make this a little bit bigger, are these. Just going to put them up here. Okay, that's what I'm going to try to find. How many calculators, how many radios, how many tape recorders. My objective is going to be however many calculators times the $10 that I'm earning. That's right there, my problem. Plus my radios, plus the $20 per radio, plus however many tape recorders times $30 that I'm getting. Okay. And my restrictions, and I have here my restrictions for cutting. Let me just put them right here so I don't have to write them all. Okay. And those are going to be my restrictions, and it has to be, all of them are going to be less than or equal to 100. Why? Because I have 100 hours for each operation, and I cannot go above that. But what is my formula? Okay, so my formula, we have the number of minutes or hours that it takes to make it. So it's going to be 20 times however many calculators. And since I'm going to pull it down and I won't have to do it one by one, I'm going to go ahead and do that. Times the number of radios plus 17 times the number of tape recorders. Okay, that gives me 0. And we're going to pull the formula down just to check. In effect, right now, wiring, it's making that calculus. So I go into solver. I'm going to say here, what is my objective? This is my objective, to try to maximize my earnings. Changing what? I want to know how many calculators, radios, and tape recorders. Add my restrictions. Since they all have the same symbol, I can do them together. Okay. It's not nonlinear. I'm going to make sure it's simplex, and I'm going to make sure it's checked with a non-negativity. And there's my answer. It says that my maximum is going to be 100, and it is going to be making 5 radios. Okay, so 5 radios is going to give me the most value out of it. Let's do another one. Here it says that we have a holiday meal turkey ranch is considering buying 2 different brands of feed. Okay, we have 2 different brands of feed and blending them to provide, this is blending them so we can mix them up to provide a good low-cost diet to our turkeys. Each feed contains a variety of portions, some of the 3 nutritional ingredients. These are our 3 nutritional ingredients, okay? This one. Brand 1, this is brand 1, costs the ranch 2 cents a pound, while brand 2 costs the ranch 3 cents for 1 pound. Use linear program to determine the lowest cost. This, for lowest cost, we're going to be doing minimizing. Okay, that means that meets the minimum monthly intake requirements. So here we have it. We have that for composite 1 or ingredient 1, we need at least 90. For B, we need 48, and for C, we need 150. So again, we make our decisions. Our decisions are going to be brand 1, brand 2. And this is decisions, our variables. Our objective is going to be to maximize that. So it's going to be however much I have for brand times the 2 cents. Let's put it like that. Plus however much half of this one times the 3 cents. Okay. And my objectives, my restrictions, I'm sorry, are going to be these three. So these three restrictions, and it's going to be at least, okay? I at least need to have them, so it's going to be greater than or equal to. For the ingredient A, 90, for the ingredient B, 48, and for the ingredient C, 1.5. Okay, so here it goes. It's 5 times 10. I'm sorry, 5 times whatever I have a brand A. Brand A, if you want to put that, times the 5 plus brand B times the 10. Then whatever I have a brand 1 times 4 plus brand 2 times what I get from this composite of 3. Then brand 1 plus 0.5, and I leave it there because I don't have anything. Let me go ahead and use solver. My objective here is going to be this function, and I'm going to, this time, I'm going to try to minimize, changing what? The number of pounds that I buy of brand 1 and brand 2. My restrictions are these. Make sure I use simplex. And there's my answer. I'm going to use 8.4 pounds of brand 1 and 4.8 of brand B or brand 2. And my cost is going to be of 31 cents. Okay. Any questions